Hi and welcome in the 5-minute reviews. During these short episodes, we will try to do our best to provide you with some interesting knowledge related to .NET and specifically to .NET performance area. My name is Szymon and today what I want to talk about is the ConcurrentQueue segment. Probably you are familiar with the concurrent collections like the concurrent stack and ConcurrentQueue. So ConcurrentQueue segment is a building block for any concurrent queue. Whenever concurrent queue wants to grow, it will allocate another concurrent queue segment and it will use it if there are no previously emptied segments, of course. It will use it to store items inside of it. If we take a look at the concurrent queue segment, the algorithm behind either dequeuing or enqueuing items is quite complex. We won't be diving into it today, maybe in the future, but what I want to focus today on is the padded head and tail. So maybe you are familiar with the padding term. If you are not, let me just dive into it for a few seconds. So modern CPUs are built in the way that there is a kind of cache included in every CPU dice. If we take a look how the cache is structured, it consists of different cache lines. Cache lines, they can have different sizes. For instance, model Intel AMD CPUs, they will have 64 bytes of a single cache line. If we take a look at the other CPUs, they can have, for instance, 128 bytes. But the cache line itself, it will have some size. So if we take a look and go back to the concurrent queue segment, we will see that there is a structure called padded head and tail. And the padding means that the head and tail is moved into different places. Or if we want to be more specific, it's padded in this way or aligned in this way that the head and the tail will be placed in different cache lines depending on the CPU architecture and the cache line size that is provided by this padding helpers constant. Why is it done this way? So whenever there are two threads that want to write to the same cache line, or there is one thread that wants to write information and the other wants to read, there is the friction between these threads and one of them can be impacted. So what the padded head and tail does, basically it moves head and tail to different cache lines, ensuring that if one thread wants to write to head and the other wants to write to tail, these two writes will happen on different cache lines, and therefore the write performance or the performance of these operations won't be impacted. In other words, they won't influence each other. Of course, eventually one thread will be able to take a look at the other value if needed, but if the two threads access this data structure at the same time, writing to head one and the second to the tail, these writes are separated by moving them to different cache lines. So if we just quickly take a look where this padded head and tail is used, we will see that whenever we want to, for instance, try to dequeue, we will see that we'll take a look at the head, and eventually we will want to move the head one step further. If we go to try peek or try dequeue, try enqueue, we will see that we will operate on tail, trying to see what's the value of the tail, and later on trying to adjust the tail accordingly. So whenever you hear padding or padded, that probably means putting things or data into different areas of memory. In our case, padded head and tail means that we are moving the head and tail into specific cache line or different cache lines, ensuring that write performance or read performance of different threads will be impacted when they will access either head or the tail. That's the shortest and the most dense description on this specific example that I can give you when referring to the padded, and I'm looking forward to seeing you soon. Take care, bye.